Hey everybody, this is Larry. This is day 9 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, but also the reason why I'm always on the contest page sometimes in the beginning, even though when nothing happens, I just kind of close it, is this upper left thing. I don't know if you can see it. Hopefully you can see it, but it's claim secret reward. You click it, you get 10 coins. Yay, right? Cheers. Okay. Anyway, but one thing that I did want to additionally do is just to celebrate victories. I'm not gonna lie, I've been kind of erratic lately in performance. But yesterday I did 37th, and that's with kind of I had a typo that I was debugging for like 10 minutes, so it would have been nice to be in the top 10. But still a nice finish for the first time in a while. So yeah, I don't know, it's beeping outside for some reason. But yeah, hope everyone's doing okay. Today's problem is 144 binary tree pre-order traversal, a easy problem they claim, and one that I haven't done yet apparently. So it'll be a new problem to me, at least on Leetcode. Let's see what it wants. So return the pre-order traversal of its nodes value. Okay, are you serious? Recursive is true. Can you do it iteratively? I mean, yeah, but I mean it's just breadth first search of a stack, right? So I mean, not quite that, but you implement it. That's the way that I think about it. Is okay. So let's do it that way then, right? So what would yeah. So okay, let's try to do this iteratively. Let's challenge myself because I'm not going to do an extra problem today. And this is a easy, and I assume that people trust that I know how to do it recursively. So I'm just going to skip recursive today. And maybe I'll do it iteratively because. It does come in handy from time to time, especially if you do competitive programming and stuff like that, where whatchamacallit, where you run into recursive stack problems, especially if n is like 10 to the 5th or something. And this problem is only 100, so it doesn't matter. But 10 to the 5th or 10 to the 6th, then you run into stack space and stuff like that. And then you're like, okay, maybe I should have done it iteratively, but I was a little bit lazy. So yeah, so here maybe it'll be a good practice for me. So let's do it that way. So as I say, the way that I think about it is that no. So how would I do it? So this is pre-order, right? Pre-order is you want to do the current node and then get its children, right? So how would you do it? So which is like node left right. Yeah, I mean I'm thinking that maybe it is just breadth first search then, right? You just use it a queue. Is that true? No, because then you go left, and then when you go left, there's a lot of stuff I don't remember because pre-order doesn't really come up that much usually, or at least not explicitly. Some problems, like with dynamic programming or tree problems, you do it kind of implicitly as part of the understanding of the problem. But I have to remember what pre-order means. I guess pre-order is node left right. So because of that, it's not a breadth first search, so you cannot do a queue because then you'll just go node left right. But what you want is node left, dot, and then kind of go to the right afterwards. So okay. So as I said, this is probably just going to be let me just use a implicit stack, and then of course in the stack we put the root node in it, and then while length of stack is greater than 0. I don't know what I'm doing at this point, to be honest, so don't let my confidence, I don't know if I sound confident, sway you. But let me have an answer thing first. But I'm just thinking that's how I would definitely structure anyway. So current is equal to stack.pop, right? Because this is what a stack does. And then now, given this stack, we want to we process the answer, right? So this is the thing that we're doing, because that's the thing that's on top of the stack. And then now I guess that's not that bad, right? And then we just stack down append the right side, current dot right. Is that true? I don't know. If this is wrong, don't hold me to it. Yeah, and then that's pretty much it then, right? Is it? Hmm. All right. What am I supposed to return? Oh, the int. Oh, the values. Okay, so actually we want the value. Oh. Um. Oh. What a random case. I guess that's fine, but okay, fine. I mean, at least they gave it to us, and not making me get a wrong answer. But okay, that looks okay. But these inputs are kind of also crappy for actual testing, right? So let's actually add a few more. I don't know. I'm just adding random numbers. So hopefully, if this is good, then it should be good, right? Okay, so that looks good. So I'm kind of confident, mostly because that's just a really random case. Cool. First time solving this 1014, and I did it iteratively. I don't really. The thing is that, to be honest, I don't know how to explain this in a good way. It's just kind of in my mind. I'm not like, just to be full honest with like my thought process. I mean, you kind of saw most of the thought process already, but I just kind of thought, like I didn't have like a mathematical proof or ideal about how to solve this per se. I was just like, okay, if I do it this way, will it work? And then I kind of just thought through, well, whether it would work. And then after enough, like, okay, I don't see anything immediately troubling, so then let me just try it out. I think that's basically the idea. And this is also stuff that when you practice enough, then like maybe I do it another. I mean, obviously, this is kind of a little bit slower than you would expect from a easy problem per se. But let's say in a week I do a similar problem, and for some reason I need to do it iteratively. Now I have this idea of like, oh wait, I've done this something similar recently or in the past. I can just do it this way, and I don't have to prove again to myself, right? And of course, this is somewhat proof by AC, which is not quite the same as a proof, but of course, part of that is that it's almost like a proof by TDD more than AC, if that's how you want to think about it. Especially for this particular problem, you imagine that giving the benefit of the doubt that there are a lot of edge cases and stuff like that are handled for this particular problem and is reusable because that's all this problem is, right? And if not, you can write a test suite for this as well, for example, and then kind of figure it out that way. Cool. This is going to be linear time, linear space because that can grow to the number of nodes, and linear time because each node will get popped and pushed once, right? So yeah, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see you later and take care. Have a great rest of the week. Bye bye.